Hello and welcome to Practice Problems chapters 2 and 3. In this video I'm going to be going over the practice problems for chapters 2 and 3 in our book. I'll be going in a little bit more detail than what was done in the previous video, just explaining things to look out for in the questions and how to solve them maybe in a little bit more detail. So for question 1 here, we have what are we talking about when we talk about mean and median are equal to each other in the shape of the distribution. The mean and median are equal to each other, there's not going to be any skew, and the relatively shape of the distribution is going to be symmetrical. Therefore, we can take C and B because there's not going to be any skew. We can just kind of cross those off, and we know enough information based on the mean and median to tell enough about the shape, so we don't necessarily need more. Of course, more is always wanted, but it's not necessary. So the correct answer here is D. Number 2, which of the following is not included in the 5-point summary? Here we have A, mode. Remember, the other parts of the 5-point summary will be our min, max, Q1, Q2, and Q3, which are which is the information needed to form our box plot. Number 3, which of the following statistics is most resistant to inclusion of outliers? So this problem is all about understanding what it's asking for here. So first we're going to start with outliers. An outlier is something that is a data point that is extremely far away from the other data points in the set. Not always a great idea to always use your eyes to determine an outlier. We have an exact formula for it in which we develop our fences, an upper and lower fence. And with this, we take our IQR, or we have to find an interquartile range, and we're going to take our Q1 minus IQR times 1.5. 1.5 is going to represent it's 1.5 times or 150% more than the other data points that are found within the middle 50%. For our interquartile range. If we find a value that's above or below that for our fences, we consider that to be an outlier. When it comes to the other words in here, most resistant, so if you think of resistant, if something is like fire resistant, means fire is not going to affect it very much, right? So which of these statistics is resistant to the inclusion of outliers? Having an outlier included in a data set, which one of these is not going to change the data set completely? And so when we look at mean, well, mean is definitely going to be influenced by an outlier, especially if it's very large. And if mean is going to be affected by it, then so is the variance and the standard deviation, because those both use the mean in order to calculate. So it can't be any of those. So it is B, median. The best example to show this with is if you ever are looking for houses. Houses can range anywhere from, $100,000 to millions of dollars. And anytime you go to any kind of housing website, like Zillow or I don't know what other websites there are out there, you'll notice that they always report the median value of a house and not the average. Because if you take the average of houses being 100, 200,000, but then you have like an $11 million home, the average is going to be completely off. Whereas the median will still be the middle value, and it's going to help us accurately assess, how the homes are selling or how the market is for home buying. Number 4, we have a frequency distribution here, and we want to determine the class width. So once again, remember that class width is going to be the max data value minus the minimum data value all over the number of classes. So for this problem here, we would say that the minimum, or we'll go maximum value here will be 30.5, and our minimum value will be 0.5 divided by the number of classes, which is 6. Work this out, and we'll get our class width of 5, which is A. Biggest thing here is always remember that you're using the maximum and minimum value in the total data set. Don't just look at one particular area, although you could still solve it. It's truly set up to do the whole value for the entire years of service that you're looking at. Moving on to number 5. And number 5, we have a frequency distribution of 80 juvenile juvenile salmon, and here's their weights. And so when we have this frequency distribution, number 5 asks us, the distribution of the histogram for the weights of juvenile salmon appears to be what? So it's hard to look at it just in the frequency. So if we kind of do a very quick histogram, I'm just going to kind of do, this is going to be 100 to 149, and just understand that these other points here are the other grams and weights. I'm just not going to put where they're all equal to. And if we have some sort of scale over here, something like 5, 10, 15, 20, 25, and at the top 30. And the very first one, we're going to go up to about 15 here and kind of move that down, and then 10, and then this one's going to be 30, so at the very top, right? And this one's just going to be just below it. And if we kind of look at the shape of this, you can kind of see that it kind of looks more like this, which would be looking more like your left foot, right? Where your pinky moving towards the center of your big toe kind of moves in this direction. And so we would say that is a left skew, since it's your left foot. You can also call that a negative skew. Number 6 wants to know about the relative frequency of the distribution, particularly relative frequency for the class weights of 150 to 99 grams, which is found right here. So that's 10. So 10 over the total of 80 is equal to 0.125, or you can say that is 12.5%, which is A. Number 7, we're looking at the cumulative frequency, right, of less than 200 grams. So 200 is 200, and we want less than that, so we're going to be looking in this area here. And so that total of 25. And there we go, the cumulative frequency is 25. And then number 8, I really like number 8 a lot because it takes in a lot more critical thinking to solve it. And so if we're looking at we want to know the measure of the central angle of the class weights from 200 to 249 grams. So we're looking right here. So that's 30. If we were to take 30 over 80, we're going to kind of get what percent that is. So 30 over 80 is going to equal 0.375 or 37.5%. So we want to know of a circle, how much is the interior angle going to be of 37.5%. So the way we find that out is 0.375 times 360 is going to equal 135, which is going to be 135 degrees D. Moving on to number 9, we have a researcher who has a record number of loggerhead turtle nests, and so we want to know which of these choices displays the correct dot plot. So this one is just about looking at the numbers. Remember, we want to take these and you want to put them in order, and that's how they're going to be on the dot plot. So if you put them in order, you can look and then start matching to each other. Another great way to look at this is notice there's a 14 right away. If you look on the number plot here, here's a 14, here's a 14. Well, there's no dot on 14, so it can't be B, but we're good there and we're good there. And then I look at towards the bottom and I go, oh, okay, here's a 7, 7, 8, 8, so it should have 2 7s and 2 8s. So if we look here, there's 6, 7, 8, well, that one's good. B's already out. So here we have 6, well, there's no 6, so C can't be right. And then 5, well, there's a 6 here too, and that can't be right. So the only one that's left is A. And if you were to compare them all, they'll all be there. So just one way to look through them and make sure you know which one's right. Number 10, we're constructing a stem plot. So on this stem plot, once again, I kind of look at large values and lower values and start comparing them. If you look at A and B, their large and low values are equal to each other. But then I noticed that here there's 2 4s in the stems. So remember, this side is your stem and this is your leaves. This has a 4 and there's no 5s, and clearly there's some values that are 5s, and so those need to be represented in here, and they're not there, so this one can't be correct at all. So 10 has to be correct based on that. Moving on, I'm going to try to do these last couple ones real quick before my time runs out. We have another frequency distribution of log jams in a river. And so when we're looking at these log jams, we want to look at the skewness. Once again, if you create a chart, you can almost kind of see here, right? We're going to be very low and get a little higher, 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 right? And if we were to kind of almost flip this and put it on a graph, we would be very high, and then we kind of get low, and then once again that looks like your right foot, so that's going to be your right skewness. Number 12, we're looking at relative frequency for a class width of 20 to 24, so we're looking right here, and we're looking at relative frequency. It's going to be 16 over 272, which is going to equal 0.0588. We can round that up for A. Always, don't always advise rounding, but for here, it's fine. For 13, we want to do cumulative frequency, and we're looking for cumulative frequency for a class width of less than 10. So this value is 10, so 10 is not less than 10, so we're looking at everything less than 10, which are all these values. So it's going to be 103 plus 82, which equals 185, and we see that our answer is C there for our cumulative frequency. So number 14 here, I'm going to stop the video because we start getting into a little bit longer problems, and I will pick that up on the next video. I will see you then.